Hey guys, welcome to my channel. I'm LeetCoder. If you guys are new here, I pretty much do LeetCode style questions and I explain things in the simplest way possible. Today we have a pretty interesting problem that I'm very excited about. So let's go ahead and read the problem statement, right? So it says this question is called Reorder List, right? So it says we're given a head of a single linked list, right? So we're given a linked list. It says the list is represented as L0, L1, all right, cool, right? All the way up to the last element, right? When the array says they're telling us to reorder the list, right, to be in the following form, right? They want L0 to point to the last element, right, L of n, right? And then the second element, right, to point to the second to last element, right? And then the third element should point to the third to last element, right? So on and so forth, right? So they're telling us we should not modify the values of in the list nodes, right? Okay, we can't cheat, all right? So pretty much you're telling us guys, so right now this example, a regular linked list, right? 1, 2, 3, 4, right? And then they want us to point to the last element, like I said, right? The first element points to the last, right? The second element points to the second to last element, as you guys can see, right? And we should return it as one list, guys. What I'm saying when we're forming the output list, right? So yeah, guys. So now this question is a very good question because there's a lot involved here, right? We need to apply a lot of different techniques, right? So if you guys have been watching my linked list series, guys know you guys should be equipped with the tech tools, right, to really attack this problem, right? So right now there's a series of steps, there's a series of techniques that we're going to apply to this problem to help us efficiently solve it. So the way we're going to go about it, guys, is to there's going to be a two-pointer technique, right? And there's also going to be the reversing algorithm and the merging algorithm, right? So yeah, this is a very interesting problem. So now this is the same example, right? 1, 2, 3, right? You got no example. 1, 2, 3, 4, 5, right? 1 points to 5, right? To the last element, right? And then 2 points to 4, right? Because 2 is the second element, right? And then 4 is the second to the last element, right? That's why there's a perfect match, right? They went together. 3, there's no match, right? But 3 points to null, right? Because there's no match. You know what I'm saying? All right. So let's go ahead and through a couple examples real quick, all right? So you guys can see the algorithm pretty clearly. So right now, guys, I just pasted the example that's here, right? The first example, right? Just here, right? We're gonna talk about how we're gonna solve it, right? So a quick overview, right? We're gonna apply a two-pointer technique, right? So that we can find the middle element, right? And then split the list in half, right? After we do that, we're gonna reverse the second half, right? Because we want to merge it, right? We're gonna apply the merging algorithm that we talked about. We did that before, so we're gonna take 1, right? It's gonna point to 4, right? And then we're gonna keep building our output list, right? Let's go through the example really quickly, and you guys should gain the intuition, right? All right, so now guys, pre, right, the pre-verb, right, is gonna be one step behind slow, right? Right, so now slow is gonna move one at a time, and fast is gonna move twice as fast, right? By the time that fast gets to be null, right, 3 is gonna be pointing to the middle element, right? This is the same, we're gonna apply the same algorithm, guys, that we used in the palindrome linked list, right? So if you guys haven't seen that problem, you guys should, I highly suggest you guys go check it out because this is gonna make a lot more sense. All right, so we got the slow. So now so let's go ahead. All right, so we move pre points to the element that slow's pointing at currently, right? Okay, and then we're gonna move slow forward, right? Slow points to 2, and then fast is in a hurry, moves twice as fast. What I'm saying? So fast is pointing at 3, slow's at 2, right? And then now we do the next iteration, guys. What I'm saying? We point to, so pre points to wherever slow's pointing at currently, and then slow moves forward, right? After and then fast moves twice as fast, right? Boom, boom, fast is null. We exit out the while loop, right? And then now 3 is at the head of the second part of the list, right? So we're gonna split the list in half, right? So to simulate the splitting, guys, what I'm saying, pre that next, right, is gonna be pointing to null, right? So we're gonna set 2's next to null, right, to disconnect it from the original list that was there, right? So 3, 4, right? We're gonna remove that, right, by setting 2's that next to null, right? So we disconnect it from we disconnect the second part of the list, right, by setting that to null, right? So now, guys, the list that was split it, right? So I'm gonna paste it there, right? So slow was pointing at 3, right? So it's pointing at 3, right? So now, since slow pointing at 3, we are in pretty good shape, right? So we got one list, and then we got that. So this is that can now in half, right? So now we could easily just so now to build our output list, right? We would need to get the first element, right? And then point it to 4, right? And then 2 points to 3, right? But how do we get access to the last element, right? We can't do that, guys, because it's not an array, right? We don't have random access. So once we go forward in a linked list, right, we can't really go back, right? If we go forward, we get 4, right? We get the last element. We can't get the node before it, right? Because yeah, we can't go back. Once we move forward, we can't go back in a linked list, right? So in order to help us with that, guys, I'm saying we're gonna reverse the second part of the list, right? So that the last element is the first element, right? In the second list, right? And then the second to last element is the second element in the list, right? So now we could easily just apply the two-pointer technique, the node technique, right? With the merging algorithm, right? We did a problem like that, guys. And if you guys haven't seen that problem, you guys should, I highly suggest you guys go check that out. Something's gonna pop up here. Yeah, guys. So we need to do the reversal, right? So we need to remove it so that we can have access to the last element first, and so on and so forth. So, so 4 is gonna be here, right? Easy, and then 3 is gonna be there. So we just reverse the nodes, right? And now we got the last element, right? So now we can easily apply the merging algorithm, guys. I'm saying. So yeah, guys, I just moved the list that was here. I just put it here for simplicity, right? So now, guys, we get the first list, we get the second list, guys. I'm saying, so we're in pretty good shape. So now what we're gonna do, right? We're gonna use so we're gonna apply the emerging algorithm, right? So we're gonna have this L1, right? That's gonna take reference to the first part of the list, right? And the L2 that's gonna take part of the second part of the list, right? And then now, so we're gonna use those two pointers, right, to iterate through both lists, right, and then to populate thing, right. So this is the new list that we're gonna create, and that we're gonna return, right. So we create this dummy node, right. This is the same step that we took in the other video, guys. I'm saying we take this dummy node, right, because this is the thing that's gonna hold the due list, right. And then we get this cur variable that's gonna help us in populating the list, right. So cur takes reference to a dummy node, right, and then cur is gonna help us in populating the list, right. So now, let's quickly do it, right? So now, we just check, right? So we just do cur that next, right? Points to L1, right? Because L1 is the first list, right? So we need to point to it first. You know what I'm saying? So we point to it, right? Boom, boom. And then now we move L1 forward, right? And then we also have to move cur forward as well, right? You know what I'm saying? And then cur's at 1, right? And then now cur points to L2, right? Which is 4. You know what I'm saying? It's a simple merging algorithm, guys. I'm saying same steps. I'm saying so now cur L2 moves forward, right? And then cur move forward as well, right? Cur is right here now. You know what I'm saying? And then we do the same thing, right? Cur that next points to 2, right? Whatever L1's pointing at. So whatever L1's pointing at, right? We point to it, right? So we do it one at a time. We point to L1, move forward, and then we move to point to L2, move forward. That's how we do it, guys. You know what I'm saying. So L1 is at 2, right? So we point to 2, point to that node, right? And then L1 moves forward, right? L1's null, right? There's no more numbers. And then cur moves forward as well, right? Cur's at 2 now. And then now cur points to wherever 3 is pointing at, right? L2 is pointing at. So we move L2 forward as well, right? Okay. So L2 was at 3, so we point to it, and then we move L2 forward. And then, yeah, we move L3 forward as well, right? And then cur moves forward, right? And then there's no more numbers, guys. We simply return on that list, right? You guys can see this list, right, is the same list as this, right? So this is how the whole algorithm works, guys. I'm saying it's a very efficient one and a very, very good way of solving this problem, guys. I'm saying so we use a two-pointer technique. We find the middle element. Once we find the middle element, right, we reverse the second half, right, and then we just apply the merging algorithm, right? We create a new list that has those two things one at a time, right? We connect to this one and we move to this one. Easy, you know what I'm saying. So let's go ahead with the implementation, guys. Hopefully you guys were able to follow the thought process, and now let's go ahead and code that up. All right, so now what we talked about, guys. We use so we're gonna have just a couple pointers, right? So we have cur, so we have slow, right? Slow, take reference to head, right? And we have fast, right? It also takes reference to the head, right? And then we have a previous pointer, right? That's gonna be one step behind slow, so it's set to null initially. You know what I'm saying. So now we're gonna try to find the middle element, right? the midpoint. So now what we do, while fast is not equal to null, right? And fast.next is not equal to null, right? We do fast, we do pre, right? Make sure that we point it to the slow pointer, right? And then the slow pointer, right, move forward once, right? And then the fast pointer, guys, moves twice as fast, right? So slow moves forward once, and fast moves twice as fast. You know what I'm saying? So now, by the time that we get to the fast gets to null, right? Pre is gonna be pointing to the last element of the first list, right? So we set it to null, right? After we set that to null, guys, I told you guys, slow is gonna be pointing at the head of the second list, right? So now, what we're gonna do, right? We're gonna have to. I told you guys we have to reverse this. We have to reverse the second part of the list. So I'm saying. So second head, right? The second head is gonna be second head, meaning the head of the second list. What I'm saying. So we're gonna reverse. We're going to reverse, guys, the second head. So now we reverse. So we're gonna use this reverse function, right? That we're gonna apply. That we're gonna implement later on, right? And then we're gonna take that, right? So they just call this L2, just to keep it consistent, right? And then we got L1, right? Is the current head, right? The original head that we had. You know what I'm saying? And then L2, which is gonna be the other head, right? Is gonna be pointing to 4, right? I'm saying. So that's the line that we have here, right? So we got two different lists. You know what I'm saying. So now we simply create the dummy node, right? That's gonna hold our output list that we're gonna have, right? So just create a new node, right? Could give it any value you want. You know what I'm saying, doesn't matter. You know what I'm saying. So now the next thing that we're gonna do, guys, you know what I'm saying, which is gonna be essential, yeah, which is the simple merging algorithm that we know and love, right? So yeah, I'm sure that we have the list current is takes reference to a dummy, right? Then we do while L1 is not null and L2 is not null, right? Well, they're both not null, guys. What I'm saying, we keep populating the list. What I'm saying, so cur.next points to L1, right? First, right, and then we move L1 forward as well, right? The same thing that we did below, right? And then we move cur forward as well, so cur can point to the other element. You know what I'm saying. All right, so we do cur.next. They both move forward once, right? And then now we do cur.next, right? Points to whatever element L2 is pointing at. You know what I'm saying. And then we do L2 move forward as well, right? By 1. You know what I'm saying. L2 is go to L2.next. You know what I'm saying. And then we move cur forward as well. I'm saying. All right, so yeah, and after that, I got to remember to implement our reverse function, right? That we promised that we would have, right? So now this is a simple reverse function, right? So if you guys haven't seen that problem before, it's a pretty good one. So I highly suggest you guys go check that out as well. So we take reference of whatever thing, right? We're given a head, right? We're just gonna reverse it, right? So now, guys, we create so we take reference to the head, right? So we take reference, right? Go ahead, right? And then now we're gonna do while the cur is not null, right? We're gonna keep reversing. I'm saying. And you also remember to have the previous variable, right? That's gonna help us in the reversal. I'm saying. So now what we do, right? We have to store the original next pointer, right? In a temporal variable, right? Because we're gonna update the current node's next pointer, right? To point to the previous node, right? And then the previous node is gonna be the current node for the next iteration, right? And then now we need to move cur forward, right? With the original next pointer, right? So we that we stored in the temporary variable, and then we return, guys, the previous variable, because the previous variable is going to be at the head of the reverse list. What I'm saying. All right. Now let's check if we pass these small test cases. Perfect. Let's see if we pass all the test cases, guys. Oh wow, yeah, guys. No, remember to check for these original test cases. You know what I'm saying, head is null return. You know what I'm saying, so I think we should be in pretty good shape now. So yeah, guys. Yeah, I want to thank you guys for so head is null. Head that next null you return. You know what I'm saying. So yeah, guys. So I want to thank you guys for taking the time to watch this video. If you guys found value and you like this video, make sure to give me a like. If you guys are new here, make sure to subscribe because I'll be doing a lot of other videos just like this one. So I want to thank you guys for taking the time to watch this video, and I'll see you guys in the next one.